In this video we're going to look at the effect of changes in concentration on the position of equilibrium. So at GCSE you should have met the term Le Chatelier's principle. Le Chatelier's principle is the principle we use to explain the effect of changes at equilibrium. So what is Le Chatelier's principle? So Le Chatelier's principle states that if a system in equilibrium is subjected to a change, the position of equilibrium will move in the direction which opposes that change. So it's already in equilibrium, we've already got to the point where we've got all of the reactants and the products in some sort of equilibrium, there's everything present, and now we're going to make a change. What would be the effect of that change? And Le Chatelier's principle says the effect of that change would be to oppose it. So if I heat it up, it's going to try to cool down. If I add reactants, it's going to try to get rid of the reactants by converting them to products. So we're going to take each type of change in turn. We're going to start with changes in concentration. So we're going to start with changes in concentration. So let's just remind ourselves that when we're looking at Le Chatelier's principle, we're talking about reactants where we're putting reactants on the left and products on the right, but we've got both present because we're in a position of equilibrium. It might be that it's to the left and we've got more reactants. Might be that it's to the right and we've got more products, but we've got everything present. So what will happen? If I add in more reactants, well, according to Le Chatelier's principle, to oppose that change, I need to get rid of those reactants, and the only way to get rid of them in chemical systems is to convert them to products. So we're going to shift to the right because we've added to the left, so we move to the right. How else could we move to the right? Well, we could also move to the right by taking away some of the products as we form them. That's quite common in chemistry. So as I make my product, I remove it from the system, and so the equilibrium has to shift right to replace it. If I wanted to make it shift left, how could we do that? Well, if I add more products, then I'm going to have to shift left to replace to remove those added products and then turn them into reactants, or if I remove the reactants, then I'm going to shift left to replace them, according to Le Chatelier's principle. So if I add reactants, I'm going to move right. If I remove products, I'm also going to move right. But if I add products or remove reactants, I'm going to shift left. So let's have a look at that in action. There is a short video also in this section showing you this reaction that you could have a look at. So let's just have a look at what's going on. We've got this chromium species here, and I'd like you to pause the video in a second and have a think about the oxidation state of chromium in each of these two species. So have a think about what the oxidation state of chromium is in each of these two. If you've done that, you should have got +6 for both. The species on the left, the yellow one, is called chromate 6 because it's made from one chromium and oxygens, chromate 6 ion, and on the right it's called the dichromate 6 ion because they're both oxidation state 6. So let's have a think about our first change. When acid is added, here's the acid, so we're adding in to the left. So our option 2, according to Le Chatelier's principle, is we're going to move to the right to remove it. So how would we answer that in an exam question? Let's have a look. When acid is added to the potassium chromate, the equilibrium shifts to the, we said we're going to shift to the right. And the solution's going to go from what colour to what colour? So pause the video and see if you can figure it out. So there you go, you should have got that it's going to change from yellow, from the chromate to the dichromate, that's orange. It's going to go from yellow to orange. And we would say that if the concentration of a reactant increases, so we've added more H+, that's increasing H+, the position of equilibrium will shift to the right. And according to Le Chatelier's principle, so we have to get our Le Chatelier's principle into our answer to oppose the change. How does shifting right oppose the change? It reduces the concentration of the added reactant, in this case H+. So be careful, because obviously it won't always be H plus in every example, but make sure you can apply it to your examples. Okay, when water is added, so water's here. So I'm adding water. What effect is that going to have? See if you can pause the video and fill in the gaps. And if you've managed that, you should have got something like this. So when we added the water up here on the left, we shifted, sorry, up here on the right even, we shifted left to remove it, and so it went from orange to yellow. So if we add products, we're going to shift left to oppose the change and remove the products by turning them back into reactants. When alkali is added, so let's have a look. Alkali, well, there is no alkali present. So what is alkali going to do? So alkali is OH minus. Well, alkali is going to react with the H plus and turn it into water. It's going to remove the H plus. So alkali is going to take away the H plus because it's going with the alkali. So according to Le Chatelier's, we're going to have to shift to replace it. See if you can fill in the gaps. So according to Le Chatelier's principle, if the concentration of the reactants decreases, then we're going to have to shift left to replace those reactants. And so it's going to go towards that yellow side. So make sure you can explain changes in concentration and their effect on the position of equilibrium. So remember, we're not going completely left or completely right, we're still in equilibrium, we're just shifting a bit more to the left or a bit more to the right.